Part 2 of Unit 8 is about phase diagrams. Okay, let's review the changes between the three different phases, solids, liquids, and gases. We know that solids have the lowest amount of energy, liquids have the next highest amount, and the gas phase has the highest amount of energy. In case you didn't know some of these vocab words, we'll talk about it real quick. When a solid goes to a liquid, it's called melting, and when a liquid goes to a gas, that's called vaporization. When we flip that around and go from gas down to the lower energy states, a gas going to a liquid is called condensation, and a liquid going to a solid is called freezing. Hopefully you knew all those. These others may not be as common to you. Sometimes, at certain conditions, a solid can go directly to a gas. It can skip the liquid state. That's called sublimation, and the reverse of that, a gas going directly to a solid, that's called deposition. Let's take a look at what happens as we start to heat a chunk of ice, chunk of solid water. At point A, negative 25 degrees Celsius, we have a very cold piece of ice. As we start to add some heat to that ice, though, it starts absorbing energy. The temperature of the ice gets higher until it reaches 0 degrees Celsius. From points B to C, the ice is melting. It's going from the solid to the liquid state. While it's melting, the temperature is not going to increase. It's going to stay constant at 0 degrees Celsius. While we are adding heat over this range from B to C, the energy that we're adding, it's going to pulling the molecules farther apart, which is the main difference between the solid and liquid state. So the temperature is going to stay constant until all of the solid ice has turned to liquid. Then we're going to add some more heat and raise the temperature of the liquid water until it gets to point D. That's 100 degrees Celsius, the boiling point of water. From there, as the liquid water is turning into gas, as we add energy to it, the temperature is not going to increase either. It's going to stay the same until all the liquid water has turned into gas, and then the temperature of the water vapor will increase. So you need to remember that during phase changes, temperature remains constant. Now let's talk about vapor pressure. At any temperature, some molecules in a liquid have enough energy to escape the liquid state into the gas state. So as the temperature of that liquid increases, the energy of the molecules are increasing. So that means that as temperature increases, we're going to have more molecules with enough energy to escape into the gas phase. The boiling point of a liquid is the temperature at which its vapor pressure equals the atmospheric pressure. So as you heat up a liquid, you are increasing the vapor pressure until the vapor pressure of that liquid equals the air pressure around it. That's when the liquid starts to boil and all the liquid molecules are starting to escape into the gas phase. So looking at the graph, you can see that diethyl ether, it's got a relatively high vapor pressure at 0 degrees Celsius, so it's going to boil very quickly. That vapor pressure is going to increase with a relatively short temperature change. So diethyl ether is going to boil at 34.6 degrees Celsius. That's when the vapor pressure equals the atmospheric pressure for it. Ethyl alcohol or ethanol, it's got a slightly higher boiling point. It takes longer for the vapor pressure to increase. There you can see water going from 0 to 100 degrees Celsius. So the boiling point of water, 100 degrees Celsius, is when the vapor pressure of the liquid water is equal to the atmospheric pressure at sea level. And you see that ethylene glycol, it doesn't even register a vapor pressure until 60 degrees Celsius. This is the primary ingredient in car engine coolant, so it can absorb a whole lot of heat before it starts to boil. This is a phase diagram. Now let's talk about the different parts of it. It's divided into three sections: a solid, liquid, and a gas section. Temperature is on the x-axis and pressure is on the y-axis. This is usually in atmospheres. And you can see the divisions between the sections. That shows the conditions needed to make that change happen. So for a solid to go to a liquid, for it to melt, it's going to have a pressure or temperature that would correspond to any point on this line. Same thing with a liquid going to gas. It would have to correspond to a point on this line. Let's talk about a couple specific points on here. Point T, that's called the triple point. It's a specific pressure and temperature at which all three phases can exist at the same time. So you can have solids, liquids, and gases existing at the same time, but only at one specific pressure and temperature. Point C is called the critical point. Above point C, the critical point, that is where there's no distinction between liquids and gases. It's called a supercritical fluid above there. At any point along these lines, the solid to liquid line, the liquid to gas, or solid to gas line, the phases are in equilibrium. So at any pressure or temperature that corresponds to a point on these lines, that's where you've got either liquid or gas or solid or liquid existing at the same time as they go from one state to another. Looking at the phase diagram below, why is solid carbon dioxide called dry ice?